In this, we are designing nonlinear controllers for controlling the output voltage of DC to DC buck converter. That is, we are providing voltage regulation to the buck converter using the nonlinear controllers. Here we are comparing the PI controller, sliding mode control, and ANN control, artificial neural network control. All three controllers, we are comparing the performance of the converter under those controllers. Here, if you see, this is the converter. In this, input voltage is initially 24 volt, and after 0.5 seconds, it is changed to 16 volt. So 24 to 16 volt, input is varying. Output voltage should be regulated. Here, this is the 12 volt reference. And here, feedback voltage is taken, and from that error voltage is generated. And here we are converting it into per unit error. It is given to PI controller. The PI controller generates the duty ratio. Here, this is the duty ratio. Initially, it is around 0.5. After 0.5 seconds, it is increased to 0.8. And the output of the PI controller is given to the pulse generation, and the pulses generated is given to the MOSFET. Here, input power and output power is measured. From that, efficiency is calculated. Output power by input power into 100. These are the input powers, that is around 45 watts, and output power and efficiency, it is around 94% for PI controller. In this, if you see, means these two parameters we are comparing, voltage and efficiency. Here voltage, if you see, order of 12 volt, order of 12 volt. Here, if you zoom it, you can see when it is settled, those things. Okay, for PI controller, the voltage is settled around 3 millisecond, and for SMC control, it is settled around 1.5 millisecond, and for ANN controller, it is settled around 0.7. Okay, 0.7 millisecond. So the settling time is reduced for ANN controller, and for SMC controller slightly it is higher, and for PI controller it is much higher. And for PI controller there is peak overshoots. For SMC and ANN there are no peak overshoots. And efficiency, for PI controller it is around 94%, and after 0.5 seconds when the voltage is reduced, it is increased to 96%. Similarly, for sliding mode control, 94.5%, then it is increased to 95.5%. And for neural network, it is initially 97.6%, and when the voltage is reduced, it is 97.2%. So neural network controller have the more efficiency compared to the PI controller and the SMC controller in both conditions. So this is SMC controller and this is neural network controller. Converter, everything is same, only the controller changes. Okay, this is the working of buck converter voltage regulation using nonlinear controls. We are using PI controller, sliding mode control and ANN control, and the performance of the converter under such controllers are noted down. Here we are comparing two parameters, voltage and efficiency. In voltage, we are comparing the settling time when it is settled like that, and efficiency. ANN controller have lower settling time and better efficiency with variation in the input voltage.